March 30th, 2017. I'm sorry if I do a lot of coughing in this. I'm getting over a cold. Regarding the principle of atmospheric thinning, which is, with a star, atmospheres thin and eventually disappear as stars evolve, meaning the atmosphere starts really thick and dissipates and photoevaporates and leaves the star, and the star's atmosphere gets thinner and thinner and thinner, which means the thickness of it decreases considerably. As well, I got lucky today. I was on Facebook and I noticed a post that had this diagram in it. It says percentage of atmosphere, composition of Earth's atmosphere. Has Hadean, Archean, Proterozoic, and Phanerozoic in time and billions of years. Take that a little view. Notice something very important there. It begins at 4.6 billion, and towards that area, the helium and the hydrogen, which is in pink, are on the bottom to the very left, and on the top it's ammonia and, what's that word? Methane. Those are the two principal constituents of much younger stars. And Baz did me the service of fitting this in perfectly with the diagram that he made earlier. The Wolynski-Taylor Diagram. As you notice, the star cools and dies. But for the most part, it begins around 5 billion to 10 billion years. This is the little where the atmospheric composition changes between ocean world and Earth, where it stands right now. Obviously, the composition will change as the star evolves, depending on if there's water there to absorb all the CO2 and if it builds up in the atmosphere. And eventually, the atmosphere disappears as the world becomes dead and it loses its magnetic field. But that's that same diagram right up here. Notice how establishment science, they have this as the complete evolutionary timeline of Earth's atmosphere. Little did they know, they had to zoom out considerably to make the entire thing complete. And that being said, what's going on here is we have some serious assumptions that are taken as fact without any proof of them being true. And I'll go ahead and read this out to you guys. Multiple textbooks and the literature assume that Earth was always consisting of solid and liquid material. This assumption flatly rejects the possibility that Earth could have been in a gaseous or plasmatic state in earlier stages of its evolution, as suggested by the observations of billions of objects in those states of matter. The main justification for the standard assumption above is rooted in the philosophy of uniformitarianism. Means very slow change and not really what you see now is what it usually probably was in the past. And a sort of compartmentalization of the geologic sciences apart from astronomical observations, regardless if the Earth is itself a fundamentally astronomical object. So basically what happens is the astronomers got into their big group and the geologists got in their group, and they studied two different things, and then, they closed the door on each other. When they were walking through the hallways of the universities, they said, oh, those are just the dirt people. They don't know what they're talking about. Close the door on them. We're the astronomy people. We have the big telescopes. We know how all this stuff works, and they compartmentalize themselves. Little did they know, the geologists were studying an ancient star, and they are way better astronomers because they don't even need telescopes to look at an ancient star. They can reach their hand into the dirt and grab up stardust. It's that easy for them. But that being said, the evidence for the star, for Earth being the center of a gas giant, at least, is in the temperatures and pressures required to form specific types of specific types of rocks and minerals, such as kyanite, sillimanite, and andalusite. These minerals absolutely require the existence of very high pressures and temperatures to form. This meaning the very surface people walk on is the interior surface of a gas giant or star in the intermediate stages of evolution. A lot of the rocks and minerals need at least over 800 Kelvin to form, and between 0.2 and 1 gigapascal in pressure, meaning between 2,000 and 9,800 atmospheres of pressure right on the surface of the Earth for those rocks and minerals to form. And we only have 1 atmosphere of pressure right now, meaning Earth was covered in a very, 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 very thick atmosphere, and it was even thicker than that at one point. It was so thick the rocks couldn't even form at one point. And I thought this was really funny. I printed this out too because I love it when they put, you know, the question marks in some of these. Like, we don't know what's happening over there. And I'm like, yeah, they don't know. But they would know if they looked outside of themselves. But a lot of astronomers and physicists, they don't like to look outside of themselves. They like to think that they have a firm grasp of reality. And that being said, I think it would be fun to name these periods of Earth evolution instead of what stage of star they're in very Greek type terms such as Hadean, Archean, and that kind of stuff. Look up those words. Hadean comes from the hellish conditions on the previous, when the Earth was forming and whatnot. And in the Archean, which was the earliest geological age. So maybe we can call them different stages of evolution using Greek terminology. I thought that might be a little fun. But that being said, I think I made this video long enough. Baz, thank you very much for the help. If anybody else wants to throw in help, go right ahead. All right, later, y'all.